One of the things that is, a major property of light is that it has a finite speed. And so if you look out and you look at objects that are, say, 1 billion light years away, then you are looking at them as they were 1 billion years ago. And so this is, incredibly useful for people who study galaxies like myself, because if you want to see galaxies as they were in their past, see them evolve, then you just look at distant galaxies and you can actually see what's going on in terms of how they're evolving. The galaxies I'm interested in are really the biggest, most massive galaxies in the universe. The thing that's unusual about them is now when we look at them, they're really dead. They're not really doing very much. They don't have much gas. They're not forming much stars. They're just kind of sitting there. And yet they're absolutely massive galaxies. And so at some point in the past, they went through a period where they must have formed tons of stars. Lots happened. And what we're learning is that, this happened way, way in the past, much earlier than people thought, something like 1 to 2 billion years after the Big Bang. And so if you really want to understand these extreme galaxies, looking at them now, it's not that exciting. They're not doing anything. You really want to observe them, 1 or 2 billion years after the Big Bang, when all the action is happening.
I researched the most massive galaxies that formed in the early universe. So if you kind of look at the local universe and get a sense of what kind of galaxies you have around us, you can typically separate them into two components. So there's the spiral galaxies like our Milky Way, and then there are the more elliptical, not as exciting and pretty elliptical galaxies. And in the local universe, the most massive galaxies are typically the second group. So they are just round blobs, basically. And you don't really find the spiral galaxies to be the most massive things. And on top of the structural differences between these two groups, they also have different stellar populations, in the sense that spiral galaxies have ongoing star formation, whereas the elliptical galaxies are what we term dead, as in that they're not forming stars actively anymore.
Trying to wind the clock back from the galaxies we see now and think, what was this like 10, 11, 12 billion years ago, is incredibly difficult. And so what you really want to do is you want to use these powerful telescopes and take pictures of these things when they were very young, right? 10, 11, 12 billion light years away. And so you need, of course, powerful telescopes to do all this kind of stuff.
James Webb Space Telescope is basically the next Hubble Space Telescope that's going to really revolutionize what we know about the universe. And it was built specifically to become a near-infrared or mid-infrared telescope. So it will be observing at wavelengths longer than the Hubble Space Telescope. So similarly to how the Hubble Space Telescope revolutionized what we know about galaxies and the structure of the universe at early times, and when I say early, roughly halfway between after the Big Bang and to the age of the universe now. So similar to that, JWST will be observing at even further wavelengths than the Hubble Space Telescope, which means that you can start to do the same analysis that you've been doing with galaxies that are kind of closer to us and do it even further away. So it gives you the chance to actually see the indications of what are the processes that are happening in these galaxies in the very, very early universe.
The reason I spent, my life in astronomy is, I think just from when I was very, very young, you start to wonder where everything came from. Why are we here? How did the universe get to be this way? Why are things the way they are? And there's so many interesting places you can look, but to me, it was obvious that looking into outer space was the thing to do. When I was a kid, my father actually built a telescope with his bare hands. He built the whole telescope. He ground the mirror, he designed the whole thing and built it. And it was one thing I used to do with my father is this telescope that he built, it's not bought at a store, it's really handmade. Look at all sorts of things in the backyard. And I was doing that ever since I was, 11 or 12 years old. And so, I don't know, I guess astronomy's just kind of always been around in my life. And then the minute you get a chance to kind of dig your hands in and look at pictures from things like the Hubble telescope that people haven't ever seen before, and a chance to contribute a little bit, it's just incredibly exciting. You want to spend all your time doing it. It's a lot of fun.